Hey everybody, welcome to Commercial Construction Elevate the Industry podcast series hosted by yours truly, Dave Procida. I'm happy to be here with you today and I thank you for joining us. The purpose of the podcast is simple. We want everyone from owner to intern in commercial construction to understand the business better so you can make the best decisions about how you want to move forward. Now, I got to be honest with you. I was ready to do a solo episode today on exterior wall, what they call rainscreen. And I know a little bit about it and I certainly can sell it, but I got to tell you, I've got today a guest who I've known for well over 35 years. We met way back when in New Jersey, New York, Pennsylvania, in the prefabricated exterior wall business that has morphed. And it's morphed to rainscreen. That's what we're going to talk about today. Ray Picone, president of RJP Associates, is with us. Ray has got a tremendous background, and I'm going to tell you right off the bat, I'm in the business of rainscreen, and I wouldn't be in the business of rainscreen without Ray. He's helped me tremendously over the last 2 years, and we've been able to do it right, not eliminate, but mitigate the learning curve. So Ray, thanks for joining us. How you doing today?
My pleasure, Dave. Doing great today. Thank you.
Tell us a little bit about your background. And okay. I know you're older than me, but that's it.
Well, I started out in the late 70s after I got out of the service and got into exterior walls. That's all I've done all my life. I basically did resinous concrete and then phased into sales of exterior EIFS systems in the late 70s, early 80s, when it really became a dominant force in the exterior envelope industry. At that point, we were just doing basic barrier systems. We'd put sheathing on, put the insulation on, the EIFS, and just go to town and caulk the joints. We learned lessons the hard way after a few years that this was creating problems with not allowing the exterior wall to breathe. And what happened is we ended up with schools with black mold, with moisture penetration. And at that point, then we started exploring what was happening with these walls, with this system. Then we learned the hard way and started educating ourselves on rainscreen systems. Mid 1980s is when we really got into the rainscreen systems. At that point with EIFS was basically a moisture drainage system, which was an upscale to their barrier system. This allowed the moisture to get into the system and start draining out. After that, we started exploring exterior skins, which were ACM, thin set tile, fiber cement materials, UHPC, which is ultra high concrete. I mentioned terracotta, and all these systems at that point were still doing a barrier system. In other words, depending on the sealant as the one line of defense of moisture getting into the system, because the materials themselves were low pervious materials, not allowing the moisture through them. So the weak point at that point was through the joints. Once we started exploring and understanding rainscreens, then we decided that we were going to go into it full blown. And at that point, we wanted to learn more about it. And really, rainscreens are simple. There's two different types. You have a drainage cavity back system, which is the moisture drainage system, and then you have I'll call it a pressure equalized chamber, which is the most common one now with the exterior skins. It basically is a outer cladding, a terracotta, metal, anything with a low porosity, an air cavity, and then the most important point is an air and vapor barrier, which was the primary seal of the building. The outer cladding was designed to limit the amount of water that could potentially come into contact with the primary air and moisture barrier system. You have basically five forces of problems coming in. You have kinetic energy, which is basically wind pressure, gravity, which is the material sliding down the wall surface, capillary action, which wants to take the moisture into the backside and into the air cavity, and then surface tension. And at that point, we explored this and realized that all we have to do is compartmentalize chambers, pressure equalize that chamber behind the veneer, which would be anywhere from a 1/4 inch to an inch of airspace. And then at that point, the system started working. So from then, we basically just explored that and kept it going. We can utilize any type of exterior surface just about, and as long as it has a low pressure, not pressure, a low porosity of material, so that the moisture doesn't go directly through the material.
So Ray, would it be safe, I'm going to dumb it down a little bit, safe to say that a rain screen system is two parts. It's a backup wall system and then a skin, right? Which is separate. You've got a chamber, as you call it, or you've got space in there. You've got air barrier, right? Which is a impermeable membrane, which allows that wall to breathe, right?
That's correct.
Moisture in and out. You've got insulation, which, is another, I guess, barrier to water, but you want insulation that doesn't absorb water. You've got an airspace and you've got the rain screen. So the exterior actually serves as like the initial barrier for rain. But if rain gets in, it's an open joint system typically, right?
Correct.
So if rain does get in there, there's a way to get it out. Why is that so? I mean, that is so popular today because it allows the wall to breathe.
That's correct. It allows the wall to breathe. It creates a barrier and a separation between interior moisture and exterior moisture and penetration. And the key to that point is that you don't have a problem with moisture getting into what we call the stud frame or the masonry backup wall. So without that, you basically have solved the problem. Excuse me about my ears coming out. But you solved the problem of that primary situation, which is basically paralyzed these exterior envelopes for many years. They almost put the EIFS industry out of business.
Well, I got to tell you, Ray, the EIFS name, as I was growing up, because we met in the exterior wall business and my company erected the panels that your company made.
That's correct.
No framing with sheathing, and then some kind of drainage system, and usually EIFS. So there are companies like Turner that used to say they used to have in a contract no EIFS. Now that's changed, but you talk about the architects and the architectural community, and we'll get into the details of how it's built. But it does allow for some nice looking exterior skins, right?
Oh, definitely. You can do so much with carving up foam. I mean, you can create a lot of patterns at a very reasonable cost for that exterior envelope. So you can create a lot of design, a lot of architectural features that they love. Las Vegas wouldn't be here right now and Atlantic City would not be here to the extent that they are right now without the EIFS industry. Basically, driving our wall stow that were the primary players back in the 70s and 80s.
So now comes along rain screen, and now you have even more options as a designer or as an owner. Colors, right? Textures. You said it, you got ACM, terracotta, you got high performance concrete. And what are some of the other items you see on the exterior that would be considered rain screen? You said it, you can use anything.
Just about anything, that's correct.
Wood.
Wood. We've used high density wood. In fact, it's really interesting because wood is where the systems really developed in the 1800s in Norway. The Norwegians basically had masonry buildings, and they put cross bracing up and put wood framing up. That was really the first intentionally designed airspace between a exterior skin and a barrier type material. The nice part about those walls and a masonry wall, it basically, the thicker and the deeper they are, it allows moisture in, but it doesn't allow it all the way into the interior envelope. So at that point, at some point it dissipates, dries out, and moves back on again. It gets wet again, but it's all within that exterior mass, I would call it, of either concrete or cement block. So that's really where it started with the wood surfaces, et cetera, like that.
So, Ray, for our contractors and our estimators that are listening or watching or both, we're gonna take a short break, but when we come back, we're gonna take the wall from the inside out, talk about the most common types of backup wall, air barrier, insulation, and then rain screen, so people can get an idea of what this thing looks like. So we'll see you in a quick minute.
Sounds good.
Hi, I'm Patrick Ripple, founding partner of ISA Architectural. I've known that chap right there for well over 20 years.
And what a 20 years it's been. I'm Larry Windsor, partner, vice president of construction services. Our third partner, Mike Morehouse, can't be with us today.
We are the Mid-Atlantic's premier sales force for architectural building products and engineered architectural solutions. For over 15 years, we have been providing comprehensive design solutions to architects and designers all across this region, and high-quality economic product solutions to contractors and subcontractors too.
We bring products and people together. We specialize in the building envelope, everything from the weather barrier all the way out to different types of cladding. We fully understand the rainscreen principle, and we have an interior portfolio specializing in wood and metal walls and ceilings.
If you're a developer, part of a design team, architect, or interiors, or if you're a contractor, let us help you.
Visit www.isaarchitectural.com and see how we can bring value to your project.
All right, welcome back, everybody. We're here with Ray Picone, an old-time friend, RJP Associates. Ray, let's talk about a typical wall section. And I know you said there's masonry and there's cold form metal framing. Let's focus on what the cold form metal framing wall system looks like from the inside out.
Okay, starting from the interior sheathing, then you have a stud frame system, cold form metal framing, either 4-inch, 6-inch, 8-inch, depending on the height and the wind loads that you have to resist. Outboard of that is a 5/8 or 1/2-inch exterior sheathing, basically a waterproof exterior sheathing. On board of that would be a air vapor barrier membrane. That's your primary seal for the building. Outside of that then becomes an attachment system. There are two schools of thought right now on the attachment system. One would be a thermally broken system, which would be the newer Echo systems, Green Girt, that type of product, or a basic double angle, either galvanized or aluminum angles, which would support your exterior envelope, your exterior skin. Inboard of that cavity, then you have your thermal insulation of a thermofiber type material, anywhere from 2-inch to 6 inches thick, depending on the amount of insulation that the architect is requiring, the location of the building. Supporting the exterior envelope material, which would be your terracotta, your ACM, your fiber cement, even a thin set stone. At that point, the chamber between the insulation and the backside of the material is your pressure equalized chamber, is what we call that. And that is a derivative of the type of material, the thickness of the joints, and the size of your chambers that you're developing. These chambers are pretty simple. It's no more than your horizontal and vertical attachment systems that create these chambers. And at that point, then the depth of the cavity between the backside of the veneer material and the face of the insulation is determined by the architect. There's formulas to do all this now. It's pretty much simplified. And that's the basic wall. It can be either prefabricated. The panels can be slab to slab as far as just cold form framing and sheathing. The nice part about that is that you can dry in the building quickly. And in other words, just having the ABB membrane, the exterior sheathing, the framing as a part of the system, punching in the windows, and then, well, all the interior trades are working, your exterior envelope can be put on. It's basically in the same time frame as all your interior trades are progressing.
Must have listened to my podcast on prefabrication, right? Because that's exactly. Anyway, I want to go back to the air barrier because you said it's an air and vapor barrier. And I want our listeners to understand that there is a difference because an air barrier allows moisture to pass through the membrane. Okay, an air barrier stops, however, wind-blown moisture or from either pressing moisture into the building or sucking moisture out of the building. Okay, a air and vapor barrier would be anything that's impervious to water, typically used over the concrete slab face or to dissimilar metals that tie the, and this is getting technical, but to tie the permeable membrane to whatever the structure is. Anyway, that said, we did a job together recently and we looked at the job and we said, you know, we could use the typical Z bars that go horizontal, right? So you don't have to worry about where your metal studs are. And then they go vertical and they create that chamber where you put insulation in. However, we would put about 30,000 screws in about 42,000 square feet of sheathing. Now, it almost sounds ridiculous when you're talking about an air barrier, you put 30,000 holes in it. Now, if the holes, you know, if as long as it's going in steel, it'll suck it in. No, you know, the air barrier manufacturers don't care. Remember what we did at the one job to eliminate those holes and to create what they call continuous insulation?
Correct. Yes, you're talking the ecosystem that we attach from slab to slab with vertical tubes, and that worked out. That worked out beautifully. The system is a little bit more expensive to purchase, but it's a simpler system to install. And once you have all your verticals, then it's basically just putting your horizontals on to support the system that you're providing, the exterior envelope system. So yes, that's definitely is. I will call it the systems of the future, the Cadillac systems, but the contractors, I'll put it this way, the know-how contractors and subcontractors recognize that this initial additional cost for the basic product is offset by the field labor, especially in the more costly unionized areas or right to work type trades where you're paying a little bit more for your on-site labor, and it's definitely the way of the future. There's no doubt about it.
That's a good point. You know, when you talk about material, if you're in a high labor market like New York City or Jersey or a union market, or it's a prevailing wage job, it's a whole different dynamic in terms of what types of material makes sense. Now, you know, so we just booked a huge terracotta job, right? We got terracotta, we got ACM. Talk about ACM, right? There was a fire a couple of years ago in London. What happened, and why is that not a concern today?
Well, that whole sad situation there was a direct result of savings trying to put a cheap exterior skin on a building and not really following the basic rules of the ACM material. Number one, it was not a fire-rated product that they installed. Number two, they did not route and return the edges to create a caulk joint. They basically tried a simple, I'll call it a simple rainscreen system, but they did everything that you're not supposed to do. They used a combustible insulation, a styrofoam type material. They did not route and return the edges, which I mentioned. So they left the non-fire core exposed to the elements. So as soon as this fire started in this one apartment, there was no containing it. The insulation was burning, the ACM was burning, and since then I believe that two of the manufacturers have basically taken what we call a PE core off the market for them. Everything they're doing now is a fire-rated core. They took a lot of bad publicity, and it really wasn't their fault. It was an architectural and a monetary decision that drove that design of that building.
So we have, Ray, NFPA 285, which
Yes.
basically is a test on the exterior wall to make sure that doesn't happen. You create a flue and the flame just shoots up the building, right? What can you tell us about NFPA 285?
That is a test that basically it's a full-blown wall test. Just like the old, there were quite a few ASTMs in the old days that were just testing the product itself. The 285 tests the whole exterior wall system, and it's a full chamber test. And from that, they have certain parameters that you have to meet: fire promulgation, the amount of spread that it's allowed, et cetera, like that. And it's a basic test that is really required on almost every type of ACM or almost every type of exterior wall product now, as far as a safety issue.
You mentioned styrofoam, and you also mentioned thermofiber, which is a trade name. It's mineral fiber, rock
Mineral fiber, right?
And it's I think it melts at like 2100 degrees. It's what's used in fire containment assemblies on the inside of the building. So there's no concern about that. That's predominantly the insulation that's used on the outside. Now, Ray, I'd be remiss if I didn't ask you, what is the acronym ACM? What does that stand for?
ACM is basically aluminum composite materials. It's a either 4 millimeter or 6 millimeter thick product with an O2O exterior skin, an O2O interior skin, and a core at the point of either a PE core or an FR core, FR being a fire rated core. And they're laminated together and then becomes one thick composite material, 4 millimeter thick. And it's really the Cadillac of the metal plate systems, because you can all the finish is coil coated, so you have a uniform finish on the material. A lot of architects, because of the fires over in Saudi and in England, have shied away from ACM for political reasons, really, and because of, like you said, the Turners, the Tishmans have basically ruled out EIFS, and then they were starting to rule out ACM also. So a lot of architects are going to 1/8-inch plate, and that's a step up from the ACM cost-wise, but there's enough out there now, and there's enough fabricators that have brought that system to the market where you don't have the problems that you had years ago of delamination of the paint finishes, et cetera, like that, because it's all post-painted. All plate is post-painted, unless you get into titanium, zinc, those type of natural materials, which are very, very improved products for range screen systems, because there's no maintenance on them at all at that point. after they're installed.
First rain screen job I ever did was Fort Belvoir Community Hospital, and it was a couple 100,000 square feet of zinc.
Yes.
Wow.
Yep.
And it patina and everything. That's the look that they wanted.
Yep.
So like two more things before we take another break. Crash course, Ray, real quick, on how terracotta and ultra high performance concrete are made.
Oh boy. Okay. Well, as far as you're talking about like a GFRC product or an ultra high.
Yeah, like like a fiber cement.
Okay, fiber cement basically is a high density cement with chopped fiber strands in it. It's a sprayed on system. Again, you can do a lot with it design wise, as long as you have good mold makers in your shop. You can do deep cornices, 3-4 foot deep cornices, a lot of projection areas, and then at that point you can install a stud frame system so that this becomes a prefabricated system, or it can be just the exterior skin face fastened to the building.
But it's a product that is sprayed into a mold and baked.
Yeah.
Yeah. So it's
baked. Well, fiber cement is not baked. It's a sprayed on material that is basically just like cementitious concrete. It's a sprayed on. The ultra high concrete, UHPC is a heated process material, but it's still, they're all formed it's a downcast system, very similar to modular concrete, 8-inch thick concrete precast, right?
Same thing with terracotta, Ray.
Terracotta is two different types. You can form terracotta. Majority of terracotta is basically what we call spaghetti runs. They're extruded products that are formed and extruded in a shop. There's really only one or two domestic terracotta manufacturers. So this has become a problem right now due to everything with the pandemic, et cetera, like that, as far as this German and Spain, as far as being the primary manufacturers, as far as scheduling, et cetera, like that. So this is something that has to be taken into consideration, that they are becoming long range scheduling situations that you have to address.
And that is a perfect segue to our next break, because when we come back, we're going to talk about some of the issues, the good, the bad, the ugly about rainscreen. And we're going to talk about just what you said, the lead times and some of the issues with terms, as well as some of the risks about dealing with overseas manufacturers. So we'll see you in another quick minute. Hey, everybody, if you're looking for a strategic business partner who does subcontracting work on the interiors, let me tell you about the CFP Group. They are a minority business enterprise and have been in business for over 20 years. If you're interested, you can contact them by email at cfpgroup1@gmail.com or call them directly at 410-977-8568. That's 410-977-8568. Take it from me. I've done business with them, and I know they can get the job done. Hey, welcome back, everybody. We're here with Ray Picone, an old friend, RJP Associates, an expert in rainscreen, if you haven't figured that out already. Anyway, Ray, we promised that we would talk about some of the risks of dealing with overseas manufacturers. Now, you've been doing this a long time. I've been doing it for a few years, and we both have felt the sting when that happens. An example, if you order fiber cement and it's made in Germany, and you think you've got enough, you order, and it costs $30 a square foot. You don't want to order too much because it costs money. However, the cost of not having it, right, at the end of the job can be crazy. So when you bid work, right, and I know this, but when you bid work, tell our audience what some of the considerations are.
Okay, well, your terracottas, your fiber cement materials, it's like they're coming out of Switzerland, out of the South America, Spain, Germany. they've set a policy up, and they're all pretty much trying to do the same thing. And really, the American market has bowed to them. In other words, these people, the manufacturers are saying we want 50% down initially to start shop drawings. We want another 25% when we start fabrication. We want the balance paid before we put it on a boat to get to you. So you're at the mercy of the manufacturers unless you know them, and you basically tell them, you know what, if we want to buy your product, here's our terms: 20% down, 15% more when you start fabrication. We'll be up to 70% when it leaves the yards overseas on the containers. And then the last 30% is 30 days after the material arrives, and we can start inspecting it and knowing what we have. So these are the terms that when I was actually subcontracting and doing a lot of this work, that we basically tried to force the issue with them. Their rates are set on the euro. So the rate of the euro from when you negotiate with them might be $103. It changes 6 months later when your material is ready to ship, and all of a sudden you're hit with another $30,000 or $40,000 invoice to counteract the differential in the monetary exchange. So these are the things that again, the American market has allowed to develop. As far as contractors, the architects understand some of this. The owners do not, though. The owners typically, they go to a Walmart or a Target and they buy a product and they pay for that product and they walk out with it. What's happened with this industry is when you close a deal, and that's what a contractor or a subcontractor has to make clear while he's negotiating his contract with the CM or the GC, that you require this much down payment to start the ball rolling. You need 16 to 18 to 20 weeks lead time from signing contract to when you can expect material to start arriving at that site. So it's gotten to be that these exterior envelopes are in the same classification now as glass. Glass, everybody assumes that glass is a 20-week minimum delivery schedule. So
the good news is for contractors, with such a long lead time, it forces the general contractors to engage you early. They do.
Correct.
And that's a good thing, especially if you're doing the backup wall or air barrier, or hopefully both, because now you're leveraging one to get the other. Single source makes all the sense in the world. Listen to the prefab episode. And Ray said it, you said it right. As a subcontractor, negotiate the terms with the manufacturer before you give them the job. Because if you don't, you're in trouble. Negotiate. Once you negotiated those terms, then you let the general contractor know you're going to need this much money.
Correct.
Now, I can tell you this, they don't all go for it, as you know.
Yeah.
And on the last job I got, it's massive. And guess what? The owner didn't want to deal with it, but you know what they did? They gave us extra money for financing costs.
Right, yes.
And I'm going to Jesse Weisberg from Build It. He was on a couple episodes ago. You should listen to him. If you're a subcontractor and you are going to be out of pocket for material, this is a great way, and Jesse has a great way to deal with that. Okay, so It does have relevance. Now you're still going to have to come up front with the money to get the thing rolling. But if you make a payment when they have it in their containers, in Europe, then it's only 6 weeks over, right? And then you can actually get paid for it.
Correct.
So that all comes down to finessing it with the client and the manufacturer. And the terms, I should say the terms, and the lead time is only good for you if you don't miss something.
That's correct.
I tell people all the time. And as a matter of fact, we're talking about specialty businesses, right? Specialty products. And this fits it, although this is really on steroids, because When you're talking about $50 to $120 a square foot for a rain screen wall, that's a lot, right?
Yeah.
That's a lot. We're going to get to that in a second. But the point is, I say to most people, why wouldn't you do it? What's your biggest risk? And they say, well, if I figure 30 feet a day and I only get 20 feet a day, well, that's not your biggest risk. You're still going to make money.
That's right.
70% to 30% material to labor. So if you miss your labor by 20%, what are you missing it by, really? Okay. Yeah. What's the biggest risk, Ray?
As far as the whole exterior envelope, the biggest risk is not doing it correctly. As far as your field labor, your knowledge of the system, how it's supposed to perform, and why you're educating your field personnel on why they have to run a bead of sealant across that horizontal member, why they have to cover the screw head. Moisture penetrates. So if it's the stainless steel screw, we found out the hard way years ago that stainless steel is not stainless steel anymore. They've mixed different components into the stainless steel to be able to push them as a small number 10 or number 12 screw, and they corrode. It's hard to believe, but these fasteners do corrode over a period of time. A simple solution is either a touch up with a air membrane or a shot of sealant over that screw head. Solves the problem. So there's different components that the men in the field, and that was a hard lesson for us also back in the 80s and early 90s. The technicians, I'll call them technicians in the field, our field personnel, didn't really understand, and we didn't educate them. We knew on paper, we drew pretty pictures, we knew what we were supposed to do. And, in the field, the superintendent is basically saying, you've got to get 60 square feet a day. You've got to get 80 square feet a day. Well, when they start getting under the gun, all of a sudden little items get slipped. And, 2 years later, you're in litigation trying to figure out what happened, even though you're not at fault at some point.
Major trouble. And I'll add one thing to that, risk factor.
Yes.
Because I talk about risk factors again in my specialty products episode. However, the biggest difference here is if you don't get enough material, or if you
that one. Well, I apologize. That's a taken for me. I ordered 8 to 10% extra of everything, no matter what, because like you said, the cost of that material is substantial initially, but it's enormous if you're sitting out there with mast climbers and swings and you're waiting for material to be air freighted in from Spain or Germany that you're paying 3 times the price for that product. So it's a lot easier trying to discard 4,000 or 5,000 square feet of material, depending on the size of the job, after the fact.
And I'll tell you, Ray, for those who don't know, and I'm saying this again, you take a 50,000 square foot job where you've got fiber cement at $30 a square foot. Yep. You're going to order 10% more. That's $150,000. That's how can I do that?
Yep.
You have to do it because if you don't do it, you are looking for trouble. That could cost you 10 times that because the building either doesn't get complete or any number of other things that go wrong, liquidated damages, all that stuff. So if there's one thing you're in the business that you learned today, it should be that. Okay, everything else important to that is super critical. Now, Ray, let's go through real quickly.
Well, let's go one further back on that one, if you don't mind. Sure. On the negotiation, it's when you're negotiating with the manufacturer and you need attic stock and you need waste, that is the cheapest add-on to an order that you can do at the time. So in other words, they're pushing material out the door. And if you tell them you need an extra, if it's a fiber cement material, you need an extra 48 by 120 sheets, you need an extra 50 sheets or 100 sheets, you can negotiate that into your contract and just say, you know what, I need this material, I need it. And, let's buy this at 50% of the base cost. I don't want any fastener holes through it. I don't need anything else other than that product on the container.
Large format. And I love what you just said, because if it were me proposing, I would say included in my proposal is this much attic stock, and here's the value. Because if my competitor's not doing it, they're going to ask.
Yep.
And they're going to either make them do it or say, okay, if you don't need it, I want it back. Whatever.
Yes.
But that's a good point. So, Ray, give me 3 manufacturers who make terracotta.
The major players are Shildan, Boston Valley for domestic product. They're out of Buffalo, New York. Shildan is out of Germany. You have NBK out of I believe the Netherlands area, or Germany also. Excuse me, Germany also. So those are really the 3 key players. The Boston Valley is more of a formed material. They do push what I call spaghetti extrusions, but they're more of a crafted material as far as design wise. Shildan and NBK are the premier people for just volumes of material, pushing it out, cutting it, packaging it, and shipping it.
And Ray, you said something funny. Boston Valley's out of where?
Boston. Oh, I did tell you Boston. Didn't I say that?
Is it Boston?
Oh, no, I'm sorry.
Where's Boston Valley?
No, they're not. No, they're not. They're out of Buffalo.
That's
New York.
And you said that, and I'm thinking Boston Valley out of Buffalo. I just want to make that clear.
Yes.
ACM, big guys. Who are they?
The ACM, Alucobond, which would be Sobatech as far as a major, they're the worldwide size-wise, but you have Alucobond, you have Reynolbond, Alpolic. These are the major products. Really, anybody can route and return ACM if they know the systems and they know how to push extrusions, et cetera, like that. But if you're buying a finished product, then you have three or four major players that can produce material for you for the ACM. Again, it's Alpolic, Reynolbond, Alucobond are the 3 major ones.
But you got actually the guys that fabricated would be Sobatech, CEI. Who else?
CEI, Miller Clapperton. As far as in the general market where you're at, there's people, Raymond, et cetera, like that. There's certain people on the West Coast that fabricate. We've dealt, the Keith products out in Salt Lake City, et cetera, like that. So there's different manufacturers for that type of product. Plate is the same thing.
Let's go to fiber cement.
Fiber C. You've got Swiss Pearl, Equitone. Let me think. Swiss Pearl, Equitone.
I found ultra high performance concrete.
The ultra high performance concrete. The Corps of Engineers used that in the late 1980s. For basically retrofits to bridges and stuff like that. So I'm not that familiar with the different manufacturers for UHPC. It's a specialty product it's found its mark. I shouldn't say I don't know them. I haven't used them that often. I'm thinking of the different manufacturers, and I'm drawing the blank. Tacto is the main one, right?
It gets VE'd out a lot. As a matter of fact, the company that we both consult with, CJ Coakley, did a big job in DC, and they went over and saw a honeycomb panel, right? A metal panel that looks like it, but it was like maybe 1/8 of the weight, and they changed it. So look, you know what we didn't mention? One last one, porcelain. It's an upcoming finish.
Definitely.
Who provides porcelain?
Okay, porcelain is I've done a dozen buildings with porcelain. Porcelain tile. It's an expensive product to start with, but it's just a beautiful looking material. Once it's on the building and it's done correctly, it's maintenance free for the life of the building. Really, it's a Porcelanosa is your major player in the industry right now out of Spain. They have really devoted the time, effort, and money into the design of the systems. From them, you can purchase everything, including the fasteners from the AB membrane outboard. They have the in-house engineering to provide shop drawings, provide the engineering for that whole exterior envelope. So if you're willing to spend that little bit of extra, it's well worth getting that system. There are other manufacturers that will sell you just the porcelain, and then you pick up an Echo system or a Green Girt system. That, again, the industry, if you do your homework, the industry has responded to rain screen systems. There's a lot of manufacturers out there that manufacture and supply the different components systems to create a good rain screen system.
So what I like about Porcelanosa is the fact that they are a turnkey operation.
That's correct.
Now, this is important. You contractors out there, if you think you're buying, are you buying engineering from Reader North America? Are you buying engineering from Sobatech? Are you buying just panel layout? You need to know that, because it varies. Sometimes it's a menu of items you can pick, but you better know that you're getting everything. You might buy it a la carte from different sources, but don't get caught short with it, because that's disaster. Now, Ray, in closing, what types of contractors do you see evolving toward the rain screen wall system?
The main subcontractors are usually the carpenter trades. Are the ones that have been doing the membranes, the AB membranes, that have been doing the insulation. Because years ago, you had 3 different contractors on the outboard swings. You had a framing contractor that put up the studs and the sheathing. You had a roofer that came in and put up vertical membrane, because this was a new product on the thing. It wasn't basically stapling a barrier up like a Tyvek or something like that. Then you had again an insulator that was out there putting insulation on the building, and then a carpenter came along and put some type of skin on, either carpenter or plaster, depending on what the trade was. So it's pretty much evolved that these subcontractors have come out on board now with a carpentry background trade, a plastering background trade, that have been able to bring the tradesmen in and educate them, because if you're in a geographic area like down south, where your labor rate is less expensive than up north in the Northeast or out west, you can afford to put 10 men out and doing the work of what up north 4 men would be doing. And so it's an offset, but if you have the trained personnel that are doing it correctly at a higher labor rate, you're gonna benefit in the end, no doubt about it.
Think about it. And I'm not trying to talk anybody getting into business, but if you're a carpentry contractor, you're already doing the exterior walls. So you're doing a lake edge and sheathing, and depending on the market and all that, it could be $18 a square foot, and then air barrier is $7 or $8 a square foot. Right? So now you're going to say 26, 27. Yep. But you're in a catbird seat to get the rain screen, which anywhere from 45 on the low end to 100 plus on the high end. Now, what is rain screen? It's layout. Listen, drywall contractors. It's layout, framing, insulation, and finishing. Now, Correct. It sounds easy, and it's not simple, and it takes time. What you don't want to do is learn through the school of hard knocks, right? So if you are interested in a rain screen membrane, you want to contact me at my website. I'll give you all that in a few minutes, and I'll get you to Ray, whatever. There's really smart things you can do to mitigate the learning curve. I'll tell you one trade, Ray, that's dying to do this are the masons, because they're losing brickwork like crazy, right?
Correct.
Losing block and brickwork like crazy, and they're all over rainscreen. Now, if I was the labor union in charge of the brickies, the masons, I'd be doing the same thing.
Right.
So,
Correct.
Ray, in parting, what advice would you give to an aspiring contractor in the rainscreen business?
Start small. Go in and go after a couple of 2-3 story buildings that you're mobilizing. You don't have the risk of, should I use a mast climber? Should I use swings? How am I going to access this building? How am I going to feed the material? Because at this point, you've got to realize if it's being done correctly, the building is being closed in. Did you negotiate with the owner or the GC to allow so many windows to be left out so you can access your material? Because if you have to bring it up from the ground every single time that you're feeding this building, you've lost production. So you have to really plan and schedule what you're going to be doing, your different operations, different steps, and how you're going to access the building. But I've seen a couple of subs that I was brought in to try and help them out, that they were doing 30-story buildings and had never been on the outside of a building before. You know, it was sad.
Recipe for disaster.
Yeah.
And I'll end with this. One of the many, I think, appealing things about rainscreen, it's not a low cost to entry business. Like, let's say masonry and drywall, right? You've got to have credit. You've got to have bonding power, because these jobs get big fast, and you're not going to get credit or decent terms if you don't have them with your manufacturers and your suppliers. And I say suppliers because one of our sponsors, ISA, is a supplier of rainscreen. That's a subject that we're going to tackle when I interview them. Matter of fact, in 2 days. Okay, we're going to talk about how the supply business works, because you're not going to be buying directly from most manufacturers. Anyway, Ray, I got to tell you, it's been a pleasure working with you for the last year, and I look forward to many more. And I think our audience has been supercharged with information, good information from a wily fox like you, and I appreciate you sharing that information.
My pleasure. It's been fun. Like I say, I've been in the rainscreen for a long time. That system, and there's new things happening every day, and it's really been fun. It's been a challenge, but again, over the years, it's really paid off. It's been a fun ride. There's no doubt about it.
Oh, Ray, thanks again, and to those listening, thank you for joining us today. Stay safe and stay tuned. So if you have questions about starting, building, or selling your business, or anything in between, contact me 2 ways. Go to my website, adicorp.com, that's ADICORP.com, that's my last name spelled backwards, or visit me on LinkedIn. Go to David Procida and leave your messages there. Visit us on our YouTube channel at Elevate the Industry. Check us out on Instagram at Elevate Industry. Subscribe so you don't miss any episodes. Either way, we'll talk next week, and between now and then, stay safe and stay tuned. All the music for the episodes, including our theme song Elevate, was provided by DMV producer Trey Skills. If you like what you heard, follow Trey Skills on Instagram at Trey Skills, TreySkillz. That's TreySkillz.
Elevate. Elevate.